how to solve it algebraically in addition to doing the graphically stuff.
Okay.
So anyway, so let's look at this. Example number 1. Okay. We have a system of equations. We have 3x plus 4y is equal to 12. And then we have 2x plus y is equal to 10. Now yesterday, as we went through our notes, we said there's 2 ways to solve this algebraically. We could do elimination or substitution. Now in this particular case, because I have y by itself, 1y, not 2y, not 3y, not 4y, because I have y by itself, substitution might be a better method. Because I could take this second equation, and I could say y is equal to negative 2x plus 10. Now this is equation number 2, right? And this is equation number 1, right? Does that make sense to you guys?
Yeah.
Okay. So when I do this like this, let me move that over here a little bit, get that out of the way. This technically is still equation number 2. I just written it differently. So what I could do then is, because that's y, I could take equation number 2 and plug it into y on my equation number 1. Does that make sense? So I'm going to say 3x plus 4 times y is equal to 12. But remember that y is equal to this stuff, at least where the 2 intersect. They should. So I would say negative 2x plus 10. Now, if you get a little confused and you want a point where you can double check to make sure that you're doing this correctly, if you look at the screen, I have nothing but numbers and the variable x. So if I only have one variable and everything else are numbers, then I can solve x equals something, right?
Yeah.
Okay. Sometimes kids will solve for x and then plug the y, and they make a mistake. Again, this is a point where you can check all numbers and one variable x, or in some cases one variable y, but one variable is the key. So now what do I do to finish this? Distribute the 4 through, so I've got 3x plus negative 8x plus 40 is equal to 12. Okay? Combine like terms, I get negative 5x plus 40 equals 12. Subtract 40 from both sides, and I get negative 5x is equal to, what's?
Negative 28.
Negative 28. Oh, that's weird.
Yeah, I was thinking we would,
Man, that's not good.
that's a mean equation.
Did I make a mistake somewhere?
No, I got the same thing.
Yeah, me too.
No, it says that
We
y.
can try to plug it into our calculator.
Well, yeah, we'll double check with the calculator. That's a great idea. So let's divide both sides by 5, negative 5. These cancel, and I get x is equal to 28 over 5.
That's
Negative
great.
28.
No.
No, the negatives cancel.
Oh, it's negative 28.
Yeah, my God.
Now, you know what? If I do the math on that, if you plug that in a calculator, I think it's 5.6. Right? So I think it's 5.6. Now, I'm going to convert it to a decimal just for the sake of, because when we go to double check in the calculator, it'll spit out a decimal answer. And yeah, that's the answer in the book too, right? So we're going to pretend we don't know what the answer is. And just keep doing the work, okay? All right, so here we go. Now how do I solve for y?
Plug it in.
Do the opposite way.
Take the same equation. Take equation number 1, although you could use equation number 2, right?
Yeah.
Hey, look. I've got equation number 2 rewritten
Whoa.
in a simple way, right? I've got equation number 2 written in a simple way. What if, though, I did this work wrong?
Just
In other
use
words,
the
what if I did this wrong?
Do the original equation.
Yeah, we really should plug it into original equation. So I'm going to plug it into here, right? So I'm going to say 2x plus y equals 10. So I'm going to say 2 times x, which is what we think, 5.6 plus y equals 10. Another great place to double check some things. I got a bunch of numbers and one variable. I can solve that. So, by the way, We know this already, but notice at the beginning of this thing I had two variables and how many equations?
Two.
Two. That's no accident. You have to have one equation for every unknown variable. So 2 times 5.6 is what? 11.2?
Yep.
Plus y is equal to 10.
Negative
Subtract 11.2. Yep. 11.2. And you get y equals what?
Negative 1.2.
Negative 1.2. So now, based on all this stuff, I believe that this should intersect at 5.6, comma, negative 1.2. Can you guys do me a favor? I forgot what the original equations were. What were they?
3x
3x
plus 4y.
3x, hold on.
Plus
Plus
4y.
4y.
Alrighty.
Alright, Cole, you can just
Plus
say it,
4y equals
12, right?
buddy.
Yeah.
12. Okay, second equation was
2x
2x
plus y.
plus y equals 10.
Correct.
Alright. And we said that it would intersect at
5.6 and
1.2.
negative 1.2.
Negative.
negative 1.2.
Well, bam with the big
Bam,
sizzle.
the big.